Alright, so here we're dealing with some sort of interstellar scenario. So we have a mass of 2 kilograms, and we have this mass of 2 kilograms on 2 different planets. One is on a planet with a gravity of 19.6 meters per second squared. Ugh, it's quite strong. Okay, and we also have another scenario where this 2 kilogram object is also on Earth. So we need to find out what's the ratio between their maximum heights. Now, if you want to find this out, 2 separate scenarios. One is on planet X. So by planet X, I just mean this planet with this gravity over here. So split it up into 2 scenarios. So one is on Earth. Maybe I'll make Earth in green, just because, well, I mean, that planet's relatively green. And we also have planet X. Okay, now on planet Earth, of course, we know that the gravity on Earth is about, so I'll just make a subscript over here, just to say this is planet Earth. The acceleration is about negative 9.8 meters per second squared. So of course, we're treating the upward direction as positive, as usual. Okay, and it has a certain velocity being thrown up. Now, here's the trick. They have the same initial velocity on both planets, so both on planet Earth and planet X. So over here, this initial velocity on Earth is equal to the initial velocity on planet X. Just call this u meters per second, going upward, of course, so we'll just keep this as positive. So I can write the same thing for planet X. So this is still u meters per second. Just while I'm at it, I'll just establish that the acceleration on planet X is this gravitational acceleration here. So negative 19.6 meters per second squared. Okay, now if you want the maximum height, then you want the velocity, the final velocity, to equal to 0. So you can say that, I'll just ignore subscripts now, because you can see that the only thing that differentiates these 2 planets is just the acceleration due to gravity. So this one over here is still 0, and on planet X we also want when the velocity is 0. Okay, now the thing is, what do we want? We want the maximum height. Now the maximum height means that we want the displacement from when it's initially thrown to when the velocity is 0. So in both cases we want, okay, that's not the right pen. Okay, in both cases we want what our displacement is. What's the displacement going upward? So let's settle it one at a time. Let's talk about planet Earth first. So for Earth, well, first of all, we need an equation that relates x, v, u, and a. We can see that that is the 5th equation over here. That's what we're going to use. Now we want x, so that means we make x the subject. So x is equal to v squared minus u squared divided by 2a, just from transposition and a bit of algebra over here. We know that our variables are v is equal to 0 minus u squared. Well, I mean, we just treat that as u, just some symbol over here. We don't really need to know what that numerical value is, because what we want is the ratio between the maximum height on Earth. So just while we're at it, while we're on this point, what we want is the ratio, which is xe on the displacement on Earth relative to the displacement on this unknown planet. So let's just confirm. Maybe the other way around, actually. So what's the ratio of the maximum height objects will reach on this planet? Okay, yeah. I mean, close enough. Okay, so the height on planet X to the height on planet Earth. Okay. So the height on planet Earth will be this over here. So what do we get when we put this on the calculator? We're going to get, actually, do we need a calculator? Maybe not. These two negatives will cancel out, so we get u squared on 19.6. Okay. Now for planet X, we know that the displacement uses the very same formula, this v squared minus u squared on 2a. So final velocity is 0 minus the same initial velocity divided by 2 times its gravitational acceleration. We know that was negative 19.6. Very different from Earth. Twice as big as Earth, actually. So what does this mean for us? So this means that we just have u squared on a number twice as big as 19.6. So this would be 39.2. Okay. And remember, our goal over here is the ratio of the displacement on planet X to the displacement on planet Earth. So going back to this problem over here, this ratio is going to be equal to u squared on, not 19, 39.2 divided by u squared on 19.6. Now if you evaluate this, then you can say this 19.6 over here can go to the top. So this one here, go to your numerator. And this one, and this 39.2 can go to our denominator. So we can also say that these u squares will cancel out. So what we really get in the end is, oops, wrong color. We get 19.6 divided by 39.2. And of course we know that 39.2 is just twice as big as 19.6. So the ratio is just half. And that's our final answer.